All right, welcome back. Here we have another integral that involves, is going to eventually involve partial fractions. But in this example, we encounter that first issue that I mentioned with partial fractions. And that is for the process of partial fractions that we've set up to work, right? For the process of partial fractions. Everything we've set up, all the rules of breaking things down the way we've done, is based on the assumption that we're dealing with a fraction where the numerator has degrees smaller than the denominator. Okay, that's underlying in every one of the assumptions that we've set up. So if that's not the case, we need to make sure that is the case. And so in this example, we need to begin this problem by doing long division. Right? So we have to do our long division here. So we need to divide the denominator into the numerator. In this case, that's not going to be a very long process. Right? So we divide, and we can say, well, x squared will go into 3x squared 3 times. So we match that up above 6 because that's where constants go. And then we do our long division process. We multiply by 3. Okay, that will give me 3x squared minus 9x plus 6. And then remember the long division process. We multiplied, now we subtract, so that all the signs will change. That'll become minus 3x squared. That'll become plus 9x, and that'll become minus 6. So we go through the process here. 4x plus 9x will be 13x. Minus 6 and minus 6 will be minus 12. Okay. So that's my remainder. The degree is now smaller than what we're dividing by. So we would then write that as 3 plus 13x minus 12 over my denominator, x squared minus 3x plus 2. All right. So now my problem becomes, hey, we got to do the integral of 3 dx and the integral of this thing. Okay. So my problem now is equal to the integral of 3 dx plus this integral. And to do this integral, I'm going to want to use my partial fraction decomposition. That's going to be a whole lot easier than the alternative. That's going to be a whole lot easier than the alternative. There are alternatives there. There are other options we could use, but the partial fraction decomposition is going to be the best, especially because that denominator factors. So we can rewrite this as 13x minus 12 over that denominator, which will now be things that multiply to be 2 and add to be negative 3. That'll be x minus 1 and x minus 2 dx. Okay, so I'm just going to draw a big circle around this 3dx. We'll come back and focus on that later. Right now, we want to turn our attention to this problem here. 13x minus 12 over all that stuff. So we do our decomposition. 13x minus 12 over x minus 1 times x plus or x minus 2. So those are both linear factors, which is good. A over x minus 1 plus b over x minus 2. And then we continue our decomposition process. Now solving. So multiply by our common denominator. that'll be 13x minus 12 equals x minus 1 will go away. So that's going to be a times x minus 2. So that'll be ax minus 2a. And then b times x minus 1, bx minus b. Right? And then we equate our coefficients. So a plus b has to be 13, and minus 2a minus b has to be equal to negative 12. So that's just a basic little system, but we can still solve that. So I'm just going to go into my graphing calculator here and go to my matrix. I'm going to edit matrix A. Yes, once again, I got another stupid add. This is 2 equations, 3 columns. So we would put in 1, 1, and 13, and minus 2, minus 1, and negative 12. Okay. And then we just quit. Go to matrix again. We're going to do math. It's option B. Well, apparently it doesn't work that way. Hold on. Quit again. Second matrix. Math, I thought I could just do the letter, but apparently I can't. So I'll just scroll up, RREF. And again, second matrix. Names, matrix A. And solve. And so when I solve here, we can see we get negative 1 and 14. So A is equal to negative 1. And B is equal to 14, as our system there just said. Okay, so that means the fraction is minus 1 over x minus 1 plus 14 over x minus 2. All right, now we're ready to put it all together. So remember, we had integral of 3dx, and then that'll be plus 14 times the integral of 1 over x minus 2 dx minus 1 times the integral 1 over x minus 1 dx. All right, and we carry our process through. That'll be 3x plus 14 ln, absolute value of x minus 2, minus ln, absolute value x minus 1, and that's all plus a constant. Okay, so this one turned out to be nowhere near as bad, and that's one of the true strengths, especially when we have a linear factor in our denominator there, that we're able to handle it. Okay, or linear factors. We can make the denominator break up as linear factors, as we're able to do here. Then generally your partial fraction process is going to be a little easier. The integrals that you have to work out.